So for domain and range, I took screenshots of, I think, 5 problems. And all of them are based around these problems. So if you can do these 5, if you understand these 5, you'll understand the rest. So it says find the domain and range of the relation. Okay, domain is always your x and range is your y. I know we've talked about this, but it's easy to forget all this stuff. So then it says then determine whether the relation is a function. So first let's figure out our domain. If our domain is x, we're talking about all the x's here. So 9, 8, 7, 6. So let me see if I can, I'm just going to write it above. 9, 8, 7, 6. So that's your domain. Your range is your y. -7, -7, -7, -7. Okay, if they're all the same, just write it once. So I'm just going to write -7. You don't need to write it 4 times. Just write it once. The way it's a function is if the x's don't repeat, then it's a function. Okay, so do the x's repeat? Well, my x values were 9, 8, 7, 6. None of them repeated. The y's repeated, but it doesn't matter if the y's repeat. The x's did not repeat. So is it a function? Yes, it's a function because the x's did not repeat. Okay, this one. Find the domain and range of the function graphed below. Okay, I'm going to show you 2 different ways to do the domain and range. First of all, we're going to look at the domain. So domain is x values, right? So when I look at x's, I'm literally looking just from here to here. So I start at my left because domain is x. So I'm going to look at, this is the x-axis, this is the y-axis. So if I'm looking at the x-axis here, I'm going to trace it until I find a starting point. Here's my starting point, right? And then I'm going to keep going on the x-axis until I find the endpoint. So do you see how if I stop here, do you see how there's a point here? But if I kept going, is there any part of the graph that's on this side? There's no, the graph does not extend. I don't know why it keeps making all these weird lines. The graph doesn't extend past here. So you're going to take a look at your x values and you're going to say, okay, it's like, you can think of it as a wall. The wall is built from here to here, right? It doesn't go past this point on the x-axis, right? So from this whole line, that's all it is on the x-axis. So what is my starting point? Well, my smallest value is -2, right? For the x, my smallest value is -2. So I'm going to write -2. Now, I'm going to show you interval notation and inequality notation. So -2, remember it's a closed circle, so it gets a bracket because it's a number. And then what's my highest number is 3, and it gets a parenthesis because it's an open circle. So if it's a closed circle, bracket. If it's an open circle, parenthesis. Okay. Now, if you want to write it in inequality notation, this is interval notation, and the reason I'm showing you both is because I'm not sure what MyOpenMath wants. So if they want inequality, you're gonna do this. Okay, your domain is x, right? So I'm gonna put an x in the middle. I'm gonna put it from least to greatest. So we found out that it goes from -2 to 3, and I need to figure out my inequality signs. So my x values are greater than -2. And they stop at 3, right? So it's greater than -2, greater than or equal to, and also less than 3. So this, if we look at this separately, this says x is greater than or equal to -2. We read it from the x position. So x is greater than or equal to -2. Is that true? Yes. X gets greater than -2, right? But it's also, so I'm going to erase this part. It's also x is less than 3. Is x less than 3? Yes, because it also goes less than 3. So this is saying that x is between -2 and 3. And x is literally between -2 and 3. Now, where did I get the inequality symbols? You put an equal to sign, so it's less than or equal to or greater than or equal to if it's a closed circle. Okay, so that all goes together. Now, if it's an open circle, it's going to be those two signs. So that's why I chose this sign when it was an open circle, and I chose this sign when it was a closed circle. Okay, is there another one like this? Yeah, there's going to be. Okay, so this is how you'd write that. Now let's look at the range. The range is the y. Okay, so now this time I'm starting from bottom to top. Just like on the domain, I started from left to right. So where's my bottommost point? Well, it's here, right? So if you look there, it doesn't get any smaller than that. Well, what's this on the y-axis? This is a -5. So my smallest value is a -5. My greatest value, if I kept going up, 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 it doesn't go, there's nothing up here. My greatest value for the y is a 4. So this is my greatest value for y. This is my least value for y. Okay, so -5 to 4. The -5 gets a parenthesis because this is an open circle. And the 4 gets a bracket because unless it was an open circle, if it's a line, that means it's filled in. It's the same thing as writing like a dot there. So I'm going to do a bracket. Okay, and inequality notation, again, -5. This time it's y in the middle because we're talking about range. And you're always going to have the signs pointed like this, by the way. Always. Because this just says that y is greater than -5 and less than 4. So the signs are always going to point towards the left. You just have to figure out the equal to signs. So because this is an open circle, the one next to the -5 is going to be just less than. And then this one is going to be an equal to sign underneath. Okay, and I'm sorry, this is actually a greater than sign because we read it from the y point of view. So this says y is greater than -5. Okay. Okay, so let's look, what is the domain and range of the function in the graph? Domain is your x, so it's this line. This is always your domain. So where does it start on my x? Well, I have a point here. It starts here. I know this is on the y, but the x point of this, it might actually be easier if you label the points here. So let's label them. So it's 0, -6, and this point up here is 5, 0. So at 0, -6, what is my smallest x value? Well, we're just going to look at the x's. So I have a 0 and I have a 5. So my domain, or my x, goes from 0 to 5. What about my range? Well, my range goes from -6 to 0. So you're just going to go from smallest to greatest. Label the points on ones like these. When it's a straight line, you can just label the points. And you just take your least value of x to your greatest value of x, and your least value of y to your greatest value of y. Yeah, when it's a straight line, that's easy. Okay, now on this one says use interval notation. Did this one tell me? No, it didn't. Okay. Yeah, so I'm not sure which one this one wants, but this one specifically says interval notation, which is what we're used to. Okay, so let's look at this one. So my smallest x, again, domain, you're going to look from left to right, right? So where does the graph start? If we start at the left-hand side, and I'm like, okay, there's no graph over here, but oh, right here, that starts. So at this point right here, this is the smallest. I'm going to trace the graph and figure out where the greatest point for x is. And it's right here. So to help me, I'm going to say, okay, this is a -6 for x, and this is a 0. Kind of like the same thing that I just showed you. If we do, it's almost like putting it in a box, right? Or like a compartment. The graph doesn't go farther than either of those points. Now, what if I drew the graph like this, if I drew these dotted lines like this, you're like, wait a minute, there's still a graph over here, right? So I'm just going to kind of put these lines where the graph starts and ends for my x. So it starts at -6 and it ends at 0 for the x, -6 to 0. Okay, now I'm going to put brackets for both of these because they're closed circles. Okay, now I'm going to do the same thing for y. I'm going to go smallest to greatest. So if I trace this up, well, my smallest point for the y is here. So I can make these little, almost like compartment again. And my greatest value for y is here and here, right? Those are my greatest values. So it's going to go like this. Again, you want to just kind of trap that graph and then see where the greatest to least value is. So, or least to greatest. So my least value is -5 and my greatest value is -2. So -5, -2, and then both brackets for this. And I'm going to show you on the other one too that you can also, you could have put, so remember how like for x's we did this? And again, we wouldn't do that because there's still graph over here. So it's kind of like our barrier line. So this would be the barrier for x, which is -2 to 3, right? Which is what we got. And remember it was a parenthesis because of the open circle. And we could have also went like this. The graph starts at -5 for y and it goes to 4, right? So that's just kind of showing you how you would use those like compartments if you wanted to. And then even here, if you did the x, it would be from 0 to 5. That's where the line goes, right? And then it also goes from -6 to 0 for the range, for the y. Okay. So we have two more. So this one, it says graph the given relation. Okay, so remember this is x and this is y. This is my x line and this is my y, x-axis and y-axis. So this tells me go left 2, down 3. Left 2, down 3. This tells me left 1, down 2. So then when you have a negative in front of your x, which is your first point, that tells you go down. So this tells you if it's +1, it would be up 1, but that tells you to go down 1. I'm sorry, this tells you to go left 1. So this, if it was positive, it would tell you to go up 1. So you're gonna go down 1, left, oh my goodness gracious. I feel like I'm making this so confusing, you guys. Okay, left 1, down 2, I'm so sorry. Okay, this tells you left 1, up 1. Left 1, up 1. This tells you don't go left or right. So you stay at 0, but you're going to go up 2. Okay. This tells you, because it's positive, you're going to go right 1 and then up 3. This is right 2, up 4. Okay. Now you don't connect these, you're just going to draw the dots. And then it says the relation is a function or not a function. Well, remember the pencil test? Do you see how if I would put my pencil like this, do you see how it crosses those points twice? If it crosses it twice, it's not a function. Okay? Again, just because I completely messed up on this, I'm sorry. The x's, when they're positive, you go right. Okay, when the first number is negative, you go left. So this tells you left 1. This tells you up right 1. Now, the second number is always going to be your y. So it either tells you up or down. If it's +1, you go up 1. If it's down a -2, you go down 2. Okay. Determine if the relation represented in the table form represents y as a function of x. Okay, this represents y as a function of x is a fancy way of saying, is it a function? So tell whether the numbers in the table represent a function. So do the x's repeat? That's all we care about. The x's repeat here, so it does not represent y as a function of x because it is not a function. If the x's repeat, it's not a function. Okay, you guys, if you have any more questions on any of this, let me know. And